We are honored to have Professor Rob Miller as our next speaker. Professor Miller is a full professor in the MIT Electrical Engineering and Computer Science EECS department and a member of the Computer Science and Artificial Intelligence Laboratory. He earned bachelor's and master's degrees in computer science from MIT in 1995 and PhD from CMU. He has won an ACM Distinguished Dissertation Honorable Mentioned as NSF Career Award and 6 Best Paper Awards in US and USNIX. He has been program co-chair for US 2010, General Chair for US 2012, Associate Editor of ACM Tochi, Associate Director of MIT CSEL, and Education Co-Officer of MIT EECS. He has won 2 department awards for teaching and was named a MacFaker Faculty Fellow for outstanding contributions to MIT undergraduate education. His research interests lie at the intersection of programming and human-computer interaction, including cloud computing, online education, software development tools, and end-user programming. The title of his talk is Online Education with Learner Sourcing. Professor Rob Miller, please.
Thank you. Thank you. It's wonderful to be here. I'm going to talk about some work that my group has been working on over the last couple of years. And the big idea that I hope you take away from what I'm going to say is this notion of learner sourcing, which you should think of as crowdsourcing, where the crowd has been replaced specifically by a large group of learners, which is exactly what we see online. And the domain that we're going to think about learner sourcing is in video learning, is in improving the video content that is delivered as part of many online learning experiences. So here's some examples. On the left, you see recorded video lectures like you might see in edX or Coursera. On the right, on the top, we've got Khan Academy, which was already mentioned this morning. And on the lower right, this is just a cooking video that somebody on the internet has uploaded to YouTube. So there's a very large diversity of learning content that's appearing online. The crowd is creating instructional content as well as using instructional content. And we're thinking about this whole spectrum of information that's out there. So video has really made delivery of learning, delivery of instructional content scale. It's taken what used to be the one-on-one apprenticeship model and turned it into something that can be delivered in a MOOC to millions of people at the same time. The downside is that that's just because we're delivering it in a scalable way doesn't mean that people are actually learning in a scalable way. That traditional sort of direct interaction between a tutor and a student, or even between a lecturer and a group of students, has a lot of advantages. There's high engagement because I'm looking at you. You feel like you have to pay attention to me. I can also be aware of whether you're paying attention to me or not. I can look around the room and see how well I'm doing. And if you're falling asleep, I might become more animated. Or I might repeat what I said because you didn't hear it, right? So we get that feedback as an instructor, and we can adapt what we're doing. Even in a lecture hall scale, there's adaptation that can happen. Well, that goes away when we go to video. We've now got this mediator, this video interface between the instructor and the student and the learner. And for the learner, it's a very passive and isolated experience. You're not surrounded by other people who are giving you cues about how you should react or about whether they understand or not. You're just by yourself. And it doesn't adapt to the learner, and it can be very difficult to navigate with these video interfaces because they were really designed for television and movies. The video UI, the UI that we use for watching online learning content, whether it's a lecture or Khan Academy or a cooking video, it's the same UI that was developed for watching DVDs. right? And that's not adapted for learning. So in fact, that's going to be the area that I'm going to focus on because my group does user interface design. So we're thinking about this thing in the middle here and how we can make it work better for both the student and for the instructor. So we want to find out what learners are doing so that instructors can, in a sense, look at that sea of faces and get some feedback about what's happening with their videos. And we want the learner to be able to see more easily what's inside the video, and in particular for the video player interface to be more aware of what's inside the video so that it can present it better. Now, the idea that we're going to use to improve this video interface is crowdsourcing specialized to a crowd of learners. So crowdsourcing is it's an idea that's been around for about 10 years now. And the basic idea of it is that people out on the internet, large group of people, are doing small bits of things that allow us to solve problems that we don't know how to solve completely with artificial intelligence yet. And in return, the crowds might get small amounts of money, so that's what happens on Amazon Mechanical Turk. They might get some fun out of it. That's what happens with games with a purpose. Or they might get some social connection out of it. So Facebook, in a sense, is a large crowdsourcing platform. We're looking at how we use students, or learners in general, to do small things that improve an online course, in particular improve the videos that you get from an online course. And what we want the learners to get in return for the small amounts of work that they've done is a better learning experience themselves. I'll say a little more about that later in my talk. So there've already been examples of this idea. The discussion forums that are really essential to making MOOCs work are a kind of learner sourcing. People are choosing to answer questions that other people are posting. We have also seen peer instruction and peer grading being examples of learner sourcing, where the people in the class are helping to make the class run by teaching other people or by assessing other people's work. So learner sourcing is already happening. I'm going to talk about two variants of it that we've applied to improving videos. One variant is sort of the big data world. So we just watch what learners are doing and don't actually interrupt what they're doing. So we're collecting data about thousands or millions of people that are interacting with our content, and we're using that data to make the experience better. And then the active learner sourcing is where we're actually going to ask particular learners to do particular things that are going to improve the video content. And actually, the act of doing something is going to improve that person's own learning experience, as Dr. Terman said in his lecture a moment ago. So let me say that's going to be the outline of my talk. I'm going to show you some work we've done on the passive side, where we've taken lecture videos of MOOCs and data from lots of learners who have been watching those videos and used them to improve the video playing interface. And we're going to look also at the active learning side, where now we're taking videos from YouTube that were just uploaded by random people from the internet and added some exercises to them that allow us to improve those videos and make them easier to use. So let me dive into the passive learning side first. And this is work done by my student, Juho Kim. And so when we look at lecture videos for MOOCs, they tend to be played in an interface that has a play button and a timeline, and that's pretty much it. You don't see what else is going on in this video. They're not really optimized for seeing what's going on, and furthermore, the teacher, the person who has created that video, doesn't have any sense for whether the video is actually working. What are these moments of confusion where maybe I need to explain it better? Right? Where do people get bored and drop off? What are the aha moments? What are the very special parts of the video that maybe we should bring out? So we analyzed clickstream data from 4 different courses in edX, sort of spanning a variety of domains here, but not only STEM but also humanities. And we see a number of patterns in the way people are watching videos. There are people who just watch sequentially. So imagine this is the timeline of the video that we're seeing here. There are other people that watch for a bit and then pause and then keep playing. There are other people who watch and then rewatch parts that maybe they didn't understand or need to understand better. We see people that skip and sort of skim through the video to see what's in it. And we see people who are just jumping around. So all of these behaviors show up, and they represent sort of different parts of the video that might be important or might be interesting. So one way that we can aggregate all of this data is to take the traces of the parts of the video that each particular person has watched and simply add them up. And we end up with, this is basically the number of times that each moment of the video has been watched by someone. I'll show you one general pattern here is that the trend tends to be downward. The first parts of the video are watched much more often than the last parts of the video. But then we also see these peaks that have drawn many people using different strategies into that part of the video. And those are significant peaks where something is going on that we need to understand. And let me give you some examples of what we've learned about some of these peaks. So frequently around these peaks, there is a visual or a topical transition that occurs. So one kind of transition is when the video has made a cut. So here it was showing a piece of a Python program that the instructor is describing. And then there is a cut to the instructor's head. And what we see after that cut is a lot of people backing up to be able to keep looking at that program that they hadn't quite understood yet or they need to refer back to in order to capture, right? So one way of thinking about this is that this is where the video editor has maybe made a mistake or at least has done something that wasn't working for some of our learners, some of our students in putting that cut in there so soon. Here's another example. So when there's a visual transition just before an interaction peak, that's often a sign that it's a start of new material in this video. And people are coming in here in order to start watching that segment of the video in order to get what was in there or relearn it. What we've done with this data is used it to drive some new user interface features in the video player, right? One way we could use this data is to feed it back to the instructors, and we have done that, but it's expensive to re-record or recut videos. So what we're trying instead is to change the user interface so that the video player will do a better job of making these interaction peaks useful to people. So this is the UI. This part is where the video is playing. There's also a transcript over here on the right, which edX and Coursera and many other MOOC platforms already have. There's a part right here that I will explain in a moment and a part right here that I'll explain in a moment. So that part on the bottom, this actually shows the raw data of other users, other learners who have been watching this video. It's a profile that shows where the interaction peaks are in this video. So you can see which parts of the video other people found useful or interesting. This is actually derived from an old idea in user interfaces called readware or editware that's similar to finding the parts of a book that are heavily dog-eared or heavily bent because somebody has turned to that part of the book and read it very frequently. So a peek here is like seeing where are the other people in this class paying attention. Maybe I should pay attention to it too. We also use this data to pull out these visual highlights, which essentially capture the key slides, the key moments of that lecture. And we found that they actually correspond very well to where the peaks are. We can also use this to automatically pin a frame after a transition. So if we see many people backing up and going back to a complex slide just before a cut, what the video player will do automatically, it will freeze that frame to the side of the video player while continuing to show the playing video so that users don't have to do that backing up themselves. So these are some of the things that we can do with the big data that we get out of people watching. We've done a lab study of this using about a dozen students, both from MIT and who were taking a course on MITx, in which we gave them LectureScape, which is that UI I just showed you, versus the baseline edX interface, and observed how they behaved, and gave them several tasks that simulated what people need to do with videos, not just watch them, but also go back and look for information, and go back and find what they need to solve a problem, or go back and summarize for themselves as if they were preparing for an exam what it was that was in the video. So those are the tasks they had to do. Here's just a brief summary of the results that we found. So LectureScape enabled them to do a lot more nonlinear navigation through the video. They were using it much more in a goal-directed way rather than having to rewatch long stretches of the video. And they were exploiting all of these navigation options that we provided to them. The roller coaster that told them where the highlights were, the highlighted frames, and the pinning. And one of our learners reported that they just felt it gave them more options and personalized the strategy that they were using to navigate around. They also found when we asked them for themselves, without showing them the data, what they thought the points of importance and confusion were. Confusion correlated pretty well with the points that were coming out of the interaction peaks. Importance also found some of them as well. And I think this is really important, that when they were using the LectureScape timeline, they felt like they were there with other people. It wasn't as isolated as an experience as it would otherwise be. Now, we're in the process now of integrating this into the edX platform so that we can deploy it at a larger scale and see how it behaves with a whole classroom full of students. So that's the first part that I wanted to show you, how we can use learners' data without actually asking the learners to do something specific. For active learner sourcing, we're going to give learners a specific task to do, a little bit of micro work. And the context in which this is going to happen is in how-to videos. So YouTube is full of millions of informally amateur-produced videos about how to do things. How to create effects in Photoshop, how to cook, how to do makeup, how to fix things around your house. The challenge with these videos is that the YouTube interface is not really designed for learning. It's just a video player. It's hard to tell what's actually going on in these videos. You've got a short summary and you've got a title, but you don't really know what's inside the video. And it's hard to go to specific parts that you might be interested in. In fact, these how-to videos, they're very structured, right? It's a sequence of steps that the demonstrator is going through. So for a video about how to make a cake, there are steps to the cake recipe. First you do this, first you do that, then you do that. And even above that, there are sub-goals of the whole goal of making a cake. And in fact, there's previous work that has shown that people transfer their knowledge much better from one demonstration to another demonstration, to actually making a different cake yourself, if they're told what these sub-goals are, if they're given the higher level reasons for each of these individual groups of steps. That to make a cake, first thing you do is get all the dry ingredients and mix them together. And then the second thing you do is separately you combine the wet ingredients. That kind of sub-goal information is very powerful for learning and for transfer. So what we've done is created a video player that allows us to display these sub-goals and these steps on the left side while you have the video over here. And this acts as a navigation interface as well as basically a summary interface of what's inside the video. Now the challenge, since we've got millions and millions of videos on YouTube that don't have any of this metadata, they don't have these steps and these sub-goals, where do we get those steps and sub-goals? How are we going to get them out of the videos? The way that we're going to do it is by having the people watching the videos give them to us. And so this is the learner sourcing idea here, that we're going to get the crowd of people that are doing the learning to do small amounts of work that will improve the video, that will give us this metadata. Essentially, every minute of video that you watch, you'll get a little question. And that question will first be something like, give us the step or give us the sub-goal of the part of the video that you just watched. And it'll be a text box, and you'll type it in. And once we've collected some proposed steps and sub-goals from some learners, then the next learners to get to that point in the video will see those as a little multiple choice question here. Which of these sub-goals or steps proposed by a previous learner is the best description of what you just saw? Choose one. And then there's a third step. Once we've sort of isolated a winner, a most popular choice of how to describe that minute or so of video, then we have a final proofreading step in which other people will say, yes, that's right, no, that's wrong, or here, let me propose another way of saying it. Right? So that workflow, and crowdsourcing often has workflows of little steps like this, that workflow is now being done by the learners that are actually watching this video. So we've done a deployment of this. We deployed a website that had a sample of YouTube videos on specific topics, on web programming and on statistics, and we advertised it in various ways, social networks and Google Ads, and attracted a few thousand visitors, of whom about half of the people who came actually participated in the sense that they answered some of these learner sourcing questions. So this already is interesting, that 50% of people on the web who are just watching a how-to video are actually willing to answer these kinds of questions, right? Which is one of the questions about this kind of work. And we've gotten about 1,000 goals, about 1,000 answers through these processes, to get them through these workflows. So these people have actually done some work, even though they're not being paid to do it. We went back and, with their permission, identified some of these people and interviewed them to find out what they found useful about this process. One of the things was that they said it helped them pay attention to the video. And Dr. Terman did mention this in his talk as well, that doing something active while you are learning really does help you process it better and learn it better. And this is a small bit of active work that does that. Seeing the choices that other people had made helped the learner think that they were on the same wavelength, and also made it feel like it was a more social learning process, that there were other people here in the video with them. We also asked some of the video creators how they felt about this, and having these pop-up questions, they liked it because it meant that the viewers were actually paying attention to their video. So they thought it was a useful improvement. So I hope I've given you a sense of what we can do with the crowd of people that are learning from our materials, and that there are kind of two approaches we can take here. One is the big data approach of just watching what they're doing, but there's also an active approach where we actually ask them to do some exercises that improve the video. And I want to thank the sponsors, including NSF Quantum Computer and Google, and we also had some great collaborations with edX. Thank you very much.